polyatomic ions. So unfortunately, this is another list that you're going to need to memorize. This is the language of chemistry. If you don't know the polyatomic ions, you won't be able to name compounds, and ultimately you won't be able to balance equations. There are some patterns that are very helpful. The first is that anything that ends with ATE or 8 will have one more oxygen than the same compound that ends in ITE. So if we look over here at nitrate, that is NO3. Nitrite is NO2. The same thing happens with the chlorates, with the sulfur, and with phosphorus here at the bottom. You have a phosphate and a phosphite. And the difference is the number of oxygens. Okay, the other thing that you might want to look at is adding a hydrogen will cancel one negative charge. So here we have phosphate. It's got a phosphorus, 4 oxygens, and a -3 charge. If we add a hydrogen, we get hydrogen phosphate. It's 1 hydrogen, 1 phosphorus, 4 oxygens. That's all the same, but the charge has now gone to -2. Dihydrogen phosphate has 2 hydrogens, 1 phosphorus, 4 oxygens, and only 1 negative charge. So every time we've added a hydrogen, we've taken away a negative charge. And that occurs here. It occurs with the, looking for the carbonates. Here we go, the hydrogen carbonate. And it also happens with the hydrogen sulfide. The ones you need to memorize first are the ones that are starred. Those are the ones that are more important. So hydroxide and ammonium, the nitrate, chlorate, carbonate, cyanide, sulfate, phosphate. Those are the ones that are used most frequently. You want to be very careful, and I'll use the sulfate as an example. We have sulfate, which is SO4, 2 minus charge. We have sulfite, which is SO3 with a -2 charge. And then we also have sulfide. Remember that IDE, and that's just a plain old sulfur with no oxygen, the -2 charge. So you want to make sure you keep your sulfate, your sulfite, and your sulfide separate. And you'll have the same problem with the nitrate, the nitrite, and the nitride. And phosphorus is the same thing. Okay, so naming with polyatomic ions is pretty simple once you have the polyatomic ions memorized. So if we wanted to write barium hydroxide, we'd look up barium on the periodic table. It's in the second row, so it's got a +2 charge. Hydroxide is on our periodic, it is on the list that I just gave you, and it's up here at the very top, and it's an oxygen, a hydrogen with a negative charge. So a polyatomic ion are just ions that it's an ion, but it has more than one atom, and they kind of travel around together. We can do the crisscross just like we did for atoms, and we'll get 1 barium ion, and then we'll need 2 hydroxy ions. We have to put the brackets around it because otherwise it will look like we have 1 oxygen and 2 hydrogens. So sodium, hydrogen sulfate, sodium in the first column of the periodic table, so it looks like that. We can look at the hydrogen sulfate. It's right here, and it's HSO4. And so we can just put that together. One positive charge, one negative charge. Iron nitride. Iron, this tells how much charge the iron has. It doesn't tell how many irons there are. It just tells me that my iron has a positive 2 charge. And my nitrite is, and I just got that off the table. It's up here, nitrite. Okay, we can do our crisscross. Push it back up. We'll do a crisscross, and we get 1 iron, and we're going to have 3 nitrates. And again, we're going to need to put those in brackets to be clear about what we've got. Okay, so we can also then write the formulas. And this is where knowing those polyatomic ions becomes important. This is Na is sodium, and this is carbonate. So we have sodium carbonate. NH4 is ammonium. So we've got ammonium, and the sulfur, just sulfur by itself, is sulfide, IDE. So there's a difference. Make sure you pick that up. This would be barium phosphate. And finally, we've got tin, and that NO2 is nitrite. So this is tin. And those of you who are paying attention will notice that I left a big space between the tin and the nitrate. Tin is a transition metal, and it has more than one state, so we're going to need to use Roman numerals for it. So tin, and we don't know the charge on the tin. We know that this has a -1 charge. So if we do our crisscross up instead of going the reverse, we'll see that we need tin must have a positive 2 charge. You can always double check yourself on this. So if the tin had a positive 2 charge, and we know that the nitrate has a -1, then we'd need 2 of this. We'd need 2 of those to keep us balanced, and that's actually what they've written there.